Hi children, this is the third video of the video series Moments. In this topic we are going to discuss about uniform rods and non-uniform rods. In our small grades we have learned about the center of gravity. What do you mean by the center of gravity? The center of gravity is the point where the weight of an object acts at. If the rod is uniform, we consider the center of mass at its midpoint. For example, if you get a rod of length 2L, the center of gravity would be at a length of L from each corner. That's what you have to understand about center of gravity of a uniform rod. This question is based on a uniform rods. Let's see how to apply the theory of uniform rods for this kind of a question. The question is a uniform beam AB of mass 40 kilograms and length 5 meters. Therefore, we have to understand that the center of gravity of the rod would be at the exactly midpoint. That means 2.5 meters, half of 5 meters from each corner. So you can mark 2.5 from corner A or corner B. It doesn't matter, right? Rest horizontally in support C and D. It's rest. That means it's in equilibrium. Therefore, it should satisfy two conditions. The first condition is upwards forces equals to downwards force. So that is the basic concept we have to discuss about this question. But other than that, you have to, the basic concept is the resultant force in any direction should be 0. And the resultant moment, clockwise moment equals to anti-clockwise moment for this kind of a question, right? Since it's kept on two support C and D, where AC is 1 meters and DB also 1 meters, right? Therefore, there would be two reactions act from C and D. So still we don't know what would be the reaction. So you can mark the values, the reactions RC and RD, right? When a mass of 80 kilograms stands at beam E, so in that case, since it's standing over here, there would be a weight of 80 into gravity downwards, right? Beam E, the magnitude of the reaction at D is twice of the reaction at C. Yes, children. Here they have specifically mentioned the conditions about reaction. Therefore, you have no need of marking as RC and RD. You can write with this restriction. They mention magnitude at reaction D is twice of the magnitude reaction at C. So therefore you can mark the reaction at C as R and reaction at D as 2R. Then children, they ask about the reaction at C, rod at each corner C and D, and as well as the length of AE. What do you mean by this length of AE? Means the length where the man stands at to keep the system is in equilibrium as mentioned in the question. Now let's focus on the diagram. Since the rod is uniform, we can mark the center of gravity 2.5 from A or as well as B, right? So since it's half of the total length of the rod, 5 meters to 2.5 meters. So you can mark the weight. Weight is 40 into 9.8. Mass is 40. So therefore the weight should be 40 into 9.8. That is 392 newtons. And the weight of the man, that is 80 into 9.8 newtons, 784. He is staying at the point E. So still we don't know the length from A to E. Just keep it matter because that is one part of the question where we need to find it. And the reactions, they mention reaction at D is twice of the reaction at C. Therefore I can mark the reaction at C as R and reaction at D as 2R. With that, that is the end of the marking all the required forces in this question, right? Then we'll start with the question, right? We know that since the object is in equilibrium, if you consider the vertical equilibrium, upwards forces equals to downwards forces. What are the upwards forces? R plus 2R, that is 3R equals to 392 plus 784, the sum of the forces downwards. So if you work out, you will get the answer 3R equals to 1176, that is 392 newtons. Now you know the value for R and 2R. R would be 392 and 2R would be twice of that, right? Then to find the length from AE, where the system remain in this kind of equilibrium, you can consider the moments from any point. I prefer to consider the moment from A because that would be easier for me to get the length. So if you work out over here, you know that the clockwise moment C equals to anti-clockwise moment. So I can mark AE, the length from A to man, AE into the weight is 784 plus the weight due to the moment due to weight of the rod. I can calculate that moment by 2.5 into 392. So you can understand that if you consider from corner A, the moment due to weight of the man and weight of the rod both should be clockwise, equals to anti-clockwise moments. What are the anti-clockwise components? The moment due to the reaction R at C. So you can mark it as R into 1 meters plus 2R into 4 meters. We know that length from A to D is 4 meters. 5 minus dB 1 meter, you get the answer 4 meters. With that you can say 2R into 4 meters. If you get these figures, because now for the moment we know the value for R. Therefore you can fill up R as 392 as 2R as 784. Then you will obtain the answer for AE as 3.25 meters. So you do the calculation and see whether you also can obtain the same answer as shown in the question. Now children, this is the second question we are going to discuss under the theory of uniform rods. If you move up to the question, they mention a uniform rod of AB of length 4 meters and weight 20 newtons. With that you can understand that the weight of 20 newtons act at the entire midpoint of 4 meters. That is, from length from A to the center of gravity would be 2 meters, and from corner B even it's 2 meters. It's already mentioned over here as 2 meters. Let's try to understand the rest of the question. Is supported by horizontally 2 vertical strings at A and B. Therefore, there would be 2 tensions. Like the same way, if you keep it on 2 supports, if you hang with 2 strings, there would be 2 tensions at. I'll mark the tensions as TA and TB upwards, right? A particle of weight 10 Newton is attached to the rod at C, where AC is 1.5 meters. From AC there would be another mass, another weight of 10 Newtons. The first question they are referring is find the magnitude of the tension in the 2 strings. And then they mention the particle is so the rod of remaining horizontal equilibrium with the tension in the string B is 1.5 times of tension in string A. Find the new distance of the particle from A. We will come up with part B little bit later. Now let's try to understand the how to get the answer for the question at part A. Now children, the same concept we are discussing about. Since the object is in equilibrium, we can mark the upwards forces equals to downwards forces. So therefore you can mark TA plus TB upward forces equals to 10 plus 20 downwards forces. So you will obtain the first equation as TA plus TB equals to 30. Then I will consider the moments from A. If you consider the moments from A, clockwise moments equals to anti-clockwise moments since the object remain in equilibrium. The clockwise moments, if you consider the clockwise due to 10 newtons and 20 newtons separately. The moment due to 10 newton would be 1.5 meters into 10 newtons. The moment due to 20 newton, that is the moment due to the weight of the rod. The length from A to the center of gravity is how much, children? 1.5 plus 0.5. Other than that, you can straightforward say half of 4 meters, that is 2 meters. So that should be 2 into 20 equals to anti-clockwise moments. So if you get the TA and TB, TA is exactly work through A. So therefore that moment is TA into 0 plus TB into 4 meters. The length from A to B is 4. If you work out, you will obtain the equation independent from TA. So you will obtain the answer as 55 Newton meters. That is the sum of 1.5 into 10 plus 2 into 20. 55 Newton meters equals to 4 times of TB. With that, you will obtain the answer TB as 13.75. Now children, we know the answer for TB. We can find the value for TA substituting the TB answer into equation A. That would be 16.25. Hope you can understand how we have solved this question. Okay children, now when you come up to part B, the position of the object of weight 10 Newton is repositioned. It was changed its point. As a result, now the tension of the strings do not remain as the same value as before. If you make a slight change in a such equilibrium system, definitely the total parameters of this question varies. With that, I have changed the position of weight 10 Newton into a new position C dash. I'll get that length from A as simple X. Therefore, the tensions should changed. So in that case, they have given the new relationship between new tensions. So they mention tension at B is 1.5 times of tension at A. Therefore, I'll mark the tension at A as T and tension at B as 1.5 T. Then I'm using the same technique. Upwards forces equals to downwards forces. So you can mark up T plus 1.5 T is equals to 10 plus 30. T plus 1.5 T is 2.5 T equals to 30. With that you will obtain the answer T as 12 newtons. Now you know the figure for T. So T is 12 and 1.5 T is 1.5 to 12. That should be 18. Now to get the value for AC dash, I am using the moments around A. So each and every equation you have to do the same thing. Upwards forces equals to downwards forces. Moment around 1 point. Clockwise moments equals to anti-clockwise moment. I'll consider the moment around A. So if you consider the clockwise moments, that is due to weight of the mass and weight of the rod. So you can work out 10 into X plus 20 into 2. So that is 10 into 10 is the mass of the object with length is X, 10 into X plus 20 into 2. Mass of the rod 20, the length is 2. Therefore, you can work out 20 into 2. These clockwise moments must be similar to anti-clockwise moments. So if you consider the anti-clockwise moment, the tension, moment due to tension T at A. So that should be T into length from A to A is 0. So therefore no need of writing out that step. So no need of writing T into 0 because that answer is anyway 0. Then the tension at B is 1.5 times of T, that is 18 Newton. That is 1.5 times of 12. The length from A to that point is 4. So you can obtain the answer as 1.5 into 12 times of 4. That came from 1.5 times of T, 12. We already found the value for 12 for T at the previous step. With that, if you simplify, you will obtain the answer as X. X is the length from A to C as 3.2. So you also scribble this question or try out this question in a piece of paper and see whether can you obtain the same answer as shown in this question. Now we are moving to the second theory of today's topic, that is about non-uniform rod. The difference between uniform rods and non-uniform rod is, in uniform rod, the rod is unique, or the cross section or weight distribution, all the facts are unique. As a result, you can mark the center of gravity at the midpoint. But in a non-uniform rod, we cannot say that the center of gravity is at the midpoint of the rod. So you can mark it is in a different point as length of L1 and other part is L minus L1. Or so in certain questions we need to find this one as unknown fact. In some other questions, sometimes they used to give us the position of the new center of gravity of this non-uniform rod. We have to understand this concept from the theories. Let's try to move up to the next questions and see whether how to use this fact related to the non-uniform rods in a question. Now children, if you read out this question, when you're reading out this question, see whether what are the information you can grab from that. That is the most important point when we are working out with the question. Sam and Tasmin are sitting on a non-uniform plank AB of mass 25 and length 4 meters. Since this is non-uniform, we cannot mark the weight 25 into gravity at the midpoint 4 meters, half of 4 meters, that is 2. That is the most important point. So there should be, sometimes the point of center of gravity may be mentioned in the question, or sometimes it would be unknown fact where we need to find as an answer for this question. Let's go ahead with this question. The plank is pivoted at M, the midpoint of AB. Therefore, the length of AM and BM are half of 4 meters. That should be 2 meters, right? The center of mass AB is at Z. Yes, children, now they have given the point of center of mass in this question, where AC is 1.8. Therefore, you can mark the weight 25 into G at the point C, whereas it's 1.8 meters from A. Sam has a mass of 35 kilograms. Tasmin has a mass of 25 grams. He sits at A. So you can mark from A downwards 25 into the gravity. Then the other one, he is 35. So you can mark 35 into G, or 35 into gravity downwards from the other person, but he is not at B. That's the important point where we need to understand. Right. Where must Sam sit for the plank to be horizontal? That means they are talking about the equilibrium. Now let's see how to get the information into a question, into the answer, and see whether how to obtain the answer where this person should see to keep the system is in equilibrium. Now children, let's try to see whether what are the points they have marked in this question. You know that they have kept the object at point M, so there would be a reaction upwards. I'll mark the reaction as R. Then the center of gravity of the rod works from 1.5 meters from corner A. So I can mark 1.8. We know that M is at the midpoint. Therefore, the length from M to the center of gravity should be 2 minus 1.8. That should be 0.2 meters. If you repeat it again, the M is the midpoint of rod AB. That means the length from A to that point is 2 meters. Then the length from A to the center of gravity is 1.8. Therefore, the length from M to center of gravity should be 2 minus 1.8, that is 0.2 meters. From B to center of gravity, the point where it's kept it as M is also 2 meters, right? Then A, the person A, his weight is 25 G, where therefore you can mark 25 G vertically down from A. And the other person whose mass is 35 is not sitting at the other corner. Therefore, I will mark the length from A to that point as simple x. That is the fact we need to find it in this question. To make up the question much easier, I'll consider the moments from point A. The advantage of considering the moments from point A is then you can ignore the moment due to reaction. With that, because the reaction, they do not ask the question, the answer or the value about reaction, no need of to find that figure. Then if you consider the moments around M, the moment due to R around M is 0. What is the reason to be 0? Because M to M the length is 0. So R into 0 is 0. So no need of worrying about that. That is the reason I have considered the moment around M. Then I'll consider the anti-clockwise moment equals to clockwise moment. I have considered the anti-clockwise moments in my left hand side and clockwise moments in my right hand sides, right? What are the facts effect for clockwise moment? One is 25G and other one is also 25G. 25G, first 25G is due to the person who's sitting at A, so that moment is 25G into 2, right? The second 25G is, that is the weight of the rod. 25G to that length from M is 0.2. equals to the clockwise moment. The only clockwise moment here you can see from M is the moment due to the mass of 35g. So you can work out 35g into the length from M to that. How do you find it? Now children, we already marked the length from A to the point of 35g is x. We know the length from A to M is 2. Therefore, the length from M to that 35g should be how much? The total length is x. The length from A to M is 2. So, the other length should be x minus 2. Therefore, you can mark up 35g into x minus 2. So, if you work out over here, 25g into 2 is 50g plus 25g into 2 is 5g equals to 35g into x minus 2 is 35 xg minus 70g. Now you can see all of these terms contains g expressions. Therefore, you can cancel g from each expression and it reduces into 50 plus 5 equals to 35 minus 70. If you simplify, you will obtain the answer as x equals to 3.57. That means to keep the system is in this equilibrium, the other boy with mass 35g must be seated at a length of 3.57 meters from A. That is your final answer. Okay children, if you move up to this question. A non-uniform rod AB is 3 meters. Since it's non-uniform, the center of gravity, remember that it's not at half of 3 meters. Weight 20 newtons. Is a horizontal position resting on two supports C and D, where AC is 1 meters and AD is 2.5 meters. We will try to mark this information in the diagram and let's try to understand. The magnitude of reaction at C is 3 times of the magnitude at reaction at D. Therefore, you can mark the reaction at C is 3 times of the reaction at D. Therefore, you can mark reaction at D as R and reaction at C as 3R. Find the distance of the center of the rod, center of mass of the rod from A. That is the important point. So, in the previous question, they have given the length from center of gravity from point A. In this question, that is the fact where we need to find as your final answer. Now, let's see how to find this value after drawing a proper figure for this kind of a question. Okay children, initially we will try to mark the reactions. Reaction at D is R and reaction at C is 3R as mentioned in the question. And the center of gravity we don't know the length, therefore I'll mark the length from A to the center of gravity is X. So the weight 20 newtons act over here. Then the facts are given. The length from the A to C is 1 meters and B to D is 0.5 meters. So therefore the intermediate length should be 1.5 meters since the total length of the rod D is 4 meters, right? Okay. Then I'll consider the upwards forces equals to downwards forces. That is called the resolving vertical components. That is 3R plus R. Upwards forces equals to downwards force is 20 newtons. So if you work out 4R equals to 20, R is equals to 5 newtons, right? Then I'll consider the moments around A. If you consider the moments around A, the clockwise moments equals to anti-clockwise moments. One component of clockwise moment, that is the moment due to 20 newtons or the weight of the rod, that is x into 20, equals to anti-clockwise moment 1 into 3R plus 2.5, that is 1 plus 1.5, 2.5 into R. Now we know the values for R. R is how much? 5. Therefore you can mark up 15 into 1, that is 1 into 3R. R is 5, therefore 3R is 15. 1 into 15 plus 2.5 into 5. With that you will obtain the answer as x equals to 1.38, correct to 3 significant figures. Therefore the center of mass of this object would be 1.38 from A. Hope you have understood these contents in this video. Okay children, hopefully the content in this video is clear with you. If you like this video, put a thumbs up and share this video with your friends. To see more educational videos, subscribe my channel and click on the bell icon. See you from next videos. Thank you children.